Hello, and welcome to Systems of Two Linear Equations and Two Variables. My name's Tuesday Johnson. Here's an introduction to concept. Let's start with what linear equations and two unknowns are. A linear equation and two unknowns is an equation that can be written in the form ax plus by equals c, with a, b, and c being real numbers. All right, so a, b, and c will have numbers. X and y will be the only variables they show. The number a is called the coefficient of x, and the number b is called the coefficient of y. A solution of an equation consists of all pairs of numbers in the order x, y that satisfy this equation. So a, b, and c are numbers already. When we plug in numbers for x and y that makes the equation true, it's considered to be a solution of the equation. All right, so let's look at systems. Systems of linear equations, when two or more equations are considered together, it's called a system of equations. And if all the equations in the system are linear, we call it a linear system of equations. Mathematicians like to be very straightforward in what they're describing. The solution to a system, if one exists, consists of all points x, y that satisfy all the equations of the system at once. Now, there's three different types of solutions we might have, and the first is actually no solution. This is an inconsistent system, inconsistent with the idea of having a solution. The lines do not all intersect, or if you only have two of them, those two never touch, right? Math joke, they're never good. It's a shame that parallel lines will never meet. They have so much in common. They have the same slope, right? Same slope, different y-intercept, you're going to have no solution. One solution, these are the ones that we always hope for in the homework and definitely on exams. It's a consistent system because there is a solution. It's an independent system because the solution is independent of any of the variables. And we see this represented as the lines intersecting at a single point. This looks like 2, 5 is the solution. The third type would be an infinite solution. This is consistent because there is a solution, but it's dependent because it depends on one of the values of the variables. And it graphs as the same line. And I could have made it so the red showed, I could have made it so the blue showed, but they're the same line, so they're graphed on the same points. All right, so we can't see the both colors at the same time. So I'm going to show you what's a sledgehammer. Sure, this will always work, but it's going to destroy any sense of understanding of the problem itself. All right, so this is a great way of checking your work. We could solve a system graphically, and you could use a graphing calculator to do this. I prefer Desmos, and I'll show you why. We want to find all solutions x, y of the system of these two equations. I like to use the little squiggly brace on the side. It's called a brace. I call it a squiggly bracket. Just to identify that these two are together. You might not find that in every textbook. They might not identify these, but they're definitely grouped together in a hopefully obvious way. Our system consists of x plus y equals 3 and x minus y equals 1. Okay, so I'm going to use Desmos. And I'm going to pop up desmos.com/calculator, and I'm going to type in the equations exactly as they're written. I don't have to solve for anything. I don't have to do anything fancy. I type what I see, and Desmos will graph what I type. That's the problem. You have to make sure you type it correctly for the graph to display correctly. And then with Desmos, you could just click on the point, and it'll display for you the point of intersection, and we have our answer. This is a consistent, independent system. One solution, and the solution is the point 2, 1. When x is 2 and y is 1, both equations are true. But it's a sledgehammer. Sure, it'll work, right? But you don't want to use a sledgehammer on the trim. So sometimes we need to be a little more refined in our techniques. And here is how we're going to do that. We have three algebraic methods. And the first is intersection. So I've changed up the problem a little bit. Notice there's a 2y here instead of just y. But we want to use algebraic intersection. This method has us first solve for y in both cases. So in this top equation, to get y by itself, I'll subtract 3 to the other side, and then I will divide by 2. So y equals 3 minus x divided by 2. In the second equation, to get y by itself, I'm going to actually add y to the right and subtract 1, so I'll have x minus 1 equals y. But I wrote it in the other order because equal signs being equal signs, no. The second step of intersection is now we'll set y equal to y, right? Because we want a single point xy that works for both equations, so this y has to be the same as this y, so let's set them equal to each other. And we can use their rules that we found over here. 3 minus x over 2 equals x minus 1. My first step, I'm going to multiply both sides by 2. It cancels the denominator here. Distributes, so we have 3 minus x equals 2x minus 2. Next, I'm going to add x to both sides and add 2 to both sides. So I'll have 5 equals 3x. Dividing by 3, I find that x equals 5/3. Once we have an x value, we could use either equation, doesn't matter, top or bottom, and find the corresponding y. Well, I'm going to use the bottom equation because it looks easier. So I put 5/3 minus y equals 1. It turns out that when I solve for y, try to get y by itself, I get this exact same equation. Nice. Yes, we could have used this. I always go back to the original. I'm old school. I don't go back to anything that I've manipulated in case I made a mistake. I always make sure it works in the original. So 5/3 minus 1, remember 1 needs to be written in a fraction form as 3/3. 5 minus 3 is 2, and we keep our denominator thirds. So our y value is 2/3, and our solution for this system is 5/3, 2/3. A little bit of algebraic work, but you get to see the details. You get to see what you're actually working on. We can also use a system, an algebraic technique, called substitution. So I went back to our original equation. We already know this answer is 2, 1. But let's see how we would do it with substitution. Our first step is to solve one equation for one variable. It doesn't matter which equation. It doesn't matter which variable. I just happened to choose the top equation, and I got y by itself because I'm kind of conditioned to solve for y. Now, I use the top equation to solve for y, so my second step consists of the actual substituting. I'm going to use the second equation. Whichever equation I use to solve for y, I use the other one to substitute into. So instead of x minus y, when we know y is equal to 3 minus x, this is x minus the quantity 3 minus x. Don't forget, that minus sign distributes. That's why we use parentheses. X minus 3 plus x equals 1. That's 2x on the left. If I add 3 to both sides, 1 plus 3 is 4. 2x equals 4, x equals 2. And then we can go back, use either equation, doesn't matter. If x is 2, 2 plus what equals 3? Y must be 1. And we have our answer again of 2, 1. Yes, it's the same answer that we found graphically, quickly, easily, but that didn't use any skill or intelligence or learning. And problem solving is all about having enough tools to use the appropriate one for the situation. And graphing's not always appropriate. Let's talk about elimination. Find all solutions x, y of the following system of two equations. I went back to the one that has, 5/3, 2/3. We already know the answer. Let's look at the technique. We start by multiplying one or both equations so that one of the variables has the same value but opposite sign in both equations. What? Okay, so we are going to, in order to eliminate, we're going to end up adding these equations. And when we add these equations together, we want one of these variables to be eliminated. So I want opposite signs so that when I add them, right, they'll cancel out, but they have to have the same value. Now, since the y already has a plus 2y and a minus y, they already have opposite signs. I chose to multiply my second equation by 2. So I have 2 times x, 2 times minus y, and 2 times 1. And we have that displayed down here. My top equation stayed the same. My second equation, I multiplied every single term by 2 on the left and the right. Because now we're going to add straight down. X plus 2x is 3x. Positive 2y and negative 2y, they cancel out. They're eliminated. The y was eliminated. 3 plus 2 is 5. And if 3x equals 5, we know that x equals 5/3. And just because I chose the easy one the first time, I thought I'd use the hard one the second time, because we don't always make the easy choices in life. Sometimes we got to just work our way through it. So if x is 5/3, 5/3 plus 2y equals 3. First step, I'm going to subtract 5/3 from both sides. 3 minus 5/3, remember 3 is the same as 9/3. 9 minus 5 is 4/3. Now 2y equals 4/3, we could divide by 2, and that's the same as multiplying by a half. 1/2 of 4/3 is 2/3, and we have the same answers we had before, 5/3, 2/3. All right, these are the concepts. So we have 4 ways of solving equations. And if you follow me in my next video, I'll give you some applications and we'll actually do that for several of them, not just the same 2 systems the whole time. Thanks for watching.